Did you ever wonder how an air conditioner cool a room? The answer actually lies in the second law of thermodynamics. The second law of thermodynamics states that the total entropy change in a system must be greater than or equal to zero, and we can actually use this law to explain how heat flows. For an example, let's consider a system where two cubes are in contact, one hot and one cold. The hot cube is at 310 Kelvin, and the cold cube is at 280 Kelvin, and the heat transfer of the system is given as 3 joules. The change of entropy of a cube is given by the heat transfer divided by the temperature of the cube, and the total entropy change of this system is the sum of the entropy change of the hot and cold cubes. If we were to assume that the heat is flowing from cold to hot, in thermodynamics we define heat escaping as negative heat transfer. That would mean that the heat transfer of a cold cube is negative since heat is exiting out of the system. This would make the entropy change of the cold region to be at negative 0.0107 joules per Kelvin. Since the hot region is gaining heat, it would result in a positive entropy change at 0.0096 joules per Kelvin. Through combining both values, the total entropy change is negative 0.0011 joules per Kelvin. This value is less than zero, which cannot happen because it violates the second law. Now, let's assume that heat flows from hot to cold. Entropy change of a cold region is now positive since it is gaining heat and gives us positive 0.0107 joules per Kelvin. Entropy change of the hot region is negative since it is losing heat and gives us negative 0.0096 joules per Kelvin. The total entropy change of the system is now positive 0.0011, which agrees with second law and explains how in the real world heat flows from hot to cold. But back to the question, if heat is naturally flowing from hot to cold, how does an air conditioner cool a room? To answer this, we need to look at a key component inside the system. Typical air conditioners utilize the vapor compression cycle, which consists of a compressor, condenser, expansion valve, and evaporator, which here in this picture is the cooling coil and is the key component of how air conditioner blows cold air. The indoor air is forced inside the AC and passes through the evaporator. The evaporator contains a refrigerant inside, which is at a low pressure and kept at a lower temperature than the indoor air. Since the indoor air traveling through the evaporator is warmer, the heat naturally flows from the air into the refrigerant, just like our cube example. Because of this heat transfer, the temperature of the refrigerant increases and also evaporates due to its low pressure. From this phase change, the refrigerant is able to absorb large amounts of heat and causes the temperature of the soft air to drop, resulting in cooler air which is then pushed back out into the room and finally cooling it. After leaving the evaporator, the refrigerant is now a low-pressure vapor carrying the heat from the room. It then enters the compressor where work is added to the system by an electric motor spinning. This motor mechanically compresses the refrigerant, squeezing it into a smaller volume. As a result, the refrigerant pressure increases, and because of the work being done in it, its internal energy also increases, causing its temperature to rise significantly. After being compressed, the refrigerant flows through the condenser, and outdoor air passes over it. Just like in the evaporator, heat transfer occurs due to the temperature difference. This time, however, the refrigerant now releases heat to the surrounding because the refrigerant is hotter than the outdoor air. As the temperature of the refrigerant drops, the refrigerant is then converted from a vapor back into a liquid. It's important to note that without the work added from the compressor, this phase change in heat rejection would not be possible since the temperature of the refrigerant would not be high enough. After the compressor, the refrigerant then passes to an expansion valve where its pressure drops suddenly, which in turn lowers its temperature back to where the cycle started. The refrigerant is now ready to absorb the heat from the indoor air again, completing the vapor compression cycle. From understanding this cycle, we now know that air conditioners don't break the second law of thermodynamics, and they in fact rely on it. They use the natural flow of the heat from warm air into a colder refrigerant or hot refrigerant into the outdoor air. And that's how something as simple as heat traveling from hot to cold can make an entire room feel cool. Thank you for watching this video.